Hello, everyone. Today we're going to be multiplying polynomials. We spent the last day basically adding and subtracting, so the next logical step is to move forward in our operations. So before you guys get started, if you guys could please simplify the problem at the top of the page, that would be amazing. Pause your video now. All right, final answer's up. Hopefully you had 3x squared plus 11x minus 10. And the reason being is because, remember, when you have parentheses, we always are going to distribute the number that's out in front. So on all of these, there's either a 1 or a negative 1 that's out front, and each of those gets distributed through to any of the terms that are on the inside. All right. Now, once you multiply those numbers through, remember they only get multiplied to the number, then it's just a matter of combining like terms. Anything at the same variable raised to the same exponents, we add or subtract the numbers in front of them. So now this kind of carries through a little bit more towards today. What we did right here, our first step, in a way, you guys were actually multiplying polynomials. We just haven't really done more than a monomial other than just a number. Now, when we get into multiplying polynomials, there's something pretty significant to kind of keep in mind. And I would write this down. There's a difference between these two problems, okay? There's a difference between doing like a 2x plus a 3x and a 2x times a 3x. Now, up until this point, we've really only worked with the first case. When you add like terms, combine like terms, all we do is, it's kind of like saying we have 2 x's here and we have 3 x's here. So what we do is we don't touch the x itself. We just add the numbers in front, and that would become 5x. But when you're multiplying you did up here, we didn't have a variable to multiply through. When you multiplied this one, like for example, this 1 here through, that's not what I wanted. When you multiplied this 1 here through, you multiplied the 1 by the 6, the 2, and the -9, and we just brought the variable down. When you start multiplying variables together, this is the case where the variable's exponent is going to change. We still multiply the numbers together like normal. 2 times 3, that's not going to change how we do that. That's still going to be 6. But now when I do x times x, however many x's are there, that's going to be, if I'm multiplying 2 x's together, my exponent is going to reflect that. I'm going to say that's going to be an x squared. That just means that I multiplied 2 x's together. Now, if I had simplified this, let's say my problem had been 2x squared times 3x. Same concept. It wouldn't have really changed. We still would multiply the numbers together. 2 times 3 is 6. But now how many x's are being multiplied together? Well, I have 2 here and I have 1 here. And I know that because the exponent tells me. Then I have a total of 3. So when we start by multiplying, we're going to start simple, multiplying a polynomial by a monomial. So when we say monomial, it just means what's on the outside. There's only going to be one term on the outside. Now, we still start this kind of the same way. Whenever we see parentheses, our first thought has to be distributing. And that's exactly what we're going to do. Anything that's on the inside, we are going to multiply whatever's on the outside to whatever's on the inside. So that 2x is going to be multiplied to each of those pieces. Now, when we do that, we have to be a little careful. So I'm going to do the first one. Here, we multiply the numbers together. 2 times 6, that's going to end up giving me 12. Variables wise, I have 1x. I'm multiplying by 2 more. Because I'm multiplying, the exponent is also going to change. Okay. And then we move on. Now I'm going to take that 2x and I'm going to multiply it to the other piece as well. 2 times -3 is going to end up being -6. And here, when I do x times x, I'm multiplying 2 x's together. So that means that's going to leave me with a 6x squared. Now, because my exponents on those two variables are the same, I can't keep simplifying. Once you get rid of the parentheses, then it's all a matter of combining like terms. And when you combine like terms, that's a case where your exponents have to be the same, right? If I was adding up here, if this was a 2x plus a 3x squared, those you couldn't add together because they're not like terms. They have the same variable, but they're not being raised to the same exponent. So if we look at part B, for something like this, we are going to go through, and obviously whatever's on the outside, I'm going to start by multiplying that to each of my pieces on the inside. So let's do that first one. 6 times 4 is going to end up being 24. Y times 2 more y's is going to end up being y cubed. And now we move on. 6y times a negative 9y. Well, 6 times negative 9 is going to be a negative 54. We have 1y multiplied by 1 more. That means there's 2 y's being multiplied together. And last but not least, we have our 6y times our negative 7. 6 times negative 7 is negative 42. Now it looks kind of odd. There's 1 y. I'm not multiplying by any more y's. It just means that 1 y, it's not going to change. There's only 1 y that's ever being multiplied. Now I would check, remember simplify, I do want to check to see if there's any like terms. There's not. So that is my final answer. So I want you guys to pause your video and I want you guys to try example C. All right, this should have been your final answer. Distributing the first polynomial, you should have got 6t cubed minus 12t squared minus 45t. Once you distribute that 3t through. My second polynomial, when you distribute this 6t squared through, all right, you should be left with a 30t squared plus 12t, which here's a case where because I see I have like variables with like exponents, we have to think combined like terms. What I circled in purple, those guys are considered like terms. And what is underlined in blue is also considered like terms. So here for example B, before you go, you can choose whichever example you would like. If you want to use number 1, the distributive method, go for it. If you want to use method number 2, the box method, you can choose whichever one you would like. Okay, and now go. All right, final answers are up. So if you look, you should have got 2x squared plus 13x plus 6. No matter which method you chose, either the box method or the distributive method. All right. So if you guys could turn to the back page, the last example that we're going to go over is when you multiply just larger sizes of polynomials. And what's nice is for ones like these, usually anything more than a 2 by 2 square, this is a perfect example of one where I almost always use the box method. Just because there's going to be a lot going on. If I have a 2-term polynomial and I'm multiplying it by a 3-term polynomial, there's going to be 6 things that have to be multiplied together. Now, it doesn't mean you can't do it. No, I could take that first term, multiply it to each term in the second. That's going to give me my first 3. Then I'm going to multiply my second term, the positive 4, to each of the terms in the second. And that's going to give me my second 3 terms. So could you do it using the distributive method? Of course you can. For fun though, I'm going to show you the box method in this case. Wow, that box was awful. So since we have a 2 polynomial by a 3 polynomial, that just tells me that we're going to have a 2 by 3 box. Now you could draw it like this. You could draw it the tall way. Honestly, doesn't matter at the end of the day. It just matters that you multiply all the pieces together. So I'm going to take my 2-term polynomial and put that down on the 2 side of the box. I'm going to take my a squared minus 12a plus 1. And now we do the exact same thing. 3 times 1 is going to end up being 3. 1a times 2 more a's is going to end up being a cubed. 3 times negative 12 to fill in my next box. 3 times negative 12 is going to end up being negative 36. And a times a is going to end up being a squared. And moving forward then, 3 times 1 is going to end up being 3. Bring the a through. There's only 1 being multiplied. Moving down to my next box, 1 times 4 is going to end up being 4. Bring the a squared down. 4 times negative 12, that's going to end up being negative 48. Bring the a down. And last but not least, 1 times 4 is positive 4. And now all we have to do, you probably guessed it, is simplify. Look for any like terms. Here I don't see that many like ones. If I look at my first term, there's no other a cubes. So that guy is just going to come out. If we look towards my next one, here I do have some like terms. I have a 4a squared and a negative 36a squared. Those can be combined to be a negative 32a squared. Now you'll notice that my exponents aren't changing because I'm not multiplying. They only change when we multiply. Here we're just adding like terms. And adding like terms, all we do is we add the numbers in front. So negative 48 plus 3 for my next set ends up being a negative 45a. And there are no other plain just numbers, which makes that a 4. Okay. All right, guys. If you want to give B a shot, I'm going to be going over this in class today. If you want to try some of the special cases, though, there is one that I want to go over with you guys. And it's one that looks like this. And you're probably looking at it, and we're still multiplying, we're still simplifying. But for something like this, you're noticing that probably that there's only one polynomial, but it's being raised to the second power. Powers take that thing and multiply it by itself. So if it's a problem like this, it's really just a matter of expanding it, taking that thing, multiplying it by itself, and now we do the exact same thing. You could choose option number 1, which is our distributive method, or option number 2, which is our box method. Okay. So if you want to give a couple of the other ones I didn't do a shot, go for it. If not, you can move on and get started on the homework for today.